Hello. This video is intended to teach you how to use a debugger for the core CS classes here at UNLV. Now, if you haven't used a debugger before, that's okay. We encourage you as you move along in your computer science career that you get used to using an IDE with a debugger. For the intro course, it's okay to not use a debugger, but as you may notice as you get into upper division courses, the problems become more complicated and it can be rather difficult to figure out what's wrong with your program. The intention of this is to teach you how to fix bugs. So just to clarify on what a bug is, when you write a program, the compiler can catch mistakes that you've made if they're related to syntax or semantics. That is, if I forget a semicolon, it will mark that as a syntax error and tell me that I didn't type it out correctly. If I, for example, tried to set a string variable equal to an integer, it will tell me that I'm wrong because those two things aren't compatible. These are things that the compiler can check. However, there are other mistakes that we can make where the compiler will think it's okay, but it conflicts with our expected behavior. So for example, if I wanted to calculate the area of a circle, but I typed out code that did pi times radius instead of pi r squared, then that's going to give me incorrect output, right? The point of the debugger is to assist you when you have those sorts of mistakes, those bugs where the behavior is unexpected, and we'll walk through how this can assist us. The point of this video is to go through the basic tools that are available to you in a debugger. And I'm going to be doing this in Visual Studio because it's the debugger and IDE that I personally use most of the time. But if you use another one, that's totally okay. So if you're on Windows, I highly recommend Visual Studio. It's very helpful. If you're on Mac, the version of Visual Studio is quite different, and I recommend using something like Xcode or CLion. I don't have a lot of experience with CLion, but I've heard it's good. You can find some other IDE. Most of these features that we cover today will be shared across all IDEs. So while we're using this with Visual Studio, if you're using another debugger, please be aware that while the buttons may be a little bit different, the functionality will still be in any debugger that you use. Now, I've already installed Visual Studio, as you can see here. If you haven't already, please find it online. It's the purple one, Visual Studio Community, that I'm using here. It's freely available, and the Windows version is the one that I'm using. When you install, if you are doing C++ like we do here currently at UNLV, then you'll need to install the C++ desktop development package when you install. There will be a series of buttons, and then you'll simply click the C++ desktop development. Now, you can install a lot of different languages. You'll see that when you install it, it maybe has things about Azure databases and Python development and JavaScript and C# game development, etc. And there are a lot of different programming languages out there. So the first thing we need to do if we're going to start programming in Visual Studio is that we need to tell it what language we're working in. If we don't, then it won't be able to know exactly which compiler it needs to use and what kind of rules it's allowed to use, right? If it doesn't know if it's C++ or C# or Python, then it just cannot figure that out. So to do that, be aware, you can't just open up a file directly. You need to tell it what it's going to be working with. And the way we do that is through a thing called a project. What I'm going to do now is create a new project, and I'm going to create a project that works with C++ code. Okay. So you see here, it has this language tool, and originally mine was on C#, but you'll see I can scroll over to another language like C++, and it will show me these series of templates that we can use for building a C++ project. And all these do is they just start with some amount of actual code, if you like. So, for example, this console app will start with a file named main.cpp that says cout hello world. Some of these other ones might start with Windows Forms related things. This one might open up a DLL for you to write, right? So there's a lot of different ways you can use C++. For this project, I'm just going to start with nothing. We're going to be working in a terminal and I'm going to use no code whatsoever. So when it says empty project, unlike this one where it would maybe create a main.cpp for me, this one will create nothing. Finally, we can name it and put it somewhere on my computer. So for this, I'll do a debugger example maybe. And then when you select location, you can select somewhere on your computer. Now, I already have a folder set up, but if you'd like to save it somewhere for organization's sake, then feel free to create a folder and put it there. Okay, so we'll go ahead and hit create. And you'll see it pulls this up. Now, I don't have any code currently because I told it to make a completely empty project. In order to get code, you can do one of two things. I'm going to right click, and if I do that, you'll see there's an add button. There's two main ways that we'll add for this. The first is new item. What this will do if I click on it is it allows me to create an entirely new file. That means I can create a blank CPP file, a blank header file. I can create a text file if I go to resources, for example, or utility, right? It'll have text files. Resources may be used if you want a raw text file, or sorry, a raw image like a BMP, or you want something for color, or you want the icon that will appear down in the tray, right? If you're working on a graphics thing, you can write shaders. So it gives you a lot of flexibility with what you want to add depending on what you're working on. But for most of our courses here, you'll be creating headers, CPPs, and maybe text files, right? If you need to create a new one, just for your sake, then you can do that. However, for a lot of the assignments, we give you some code already. And if I have existing code that I want to bring into my project, I can hit add with a right click, add existing item, and then you'll see it pulls up this window. Now, this is where my code is currently saved, or is going to run my project. I have my code somewhere else on my computer. So what I'm going to do is I'm simply going to navigate over to there. I have teaching, debugger example, and then you'll see I have all my CPP and header files right here. So I'm going to simply add all of those, and then you'll see that they now appear, so I can now use all of these. What it's going to do is it's going to add these to a make file that it keeps internally for me. You don't have to run the make command, but it will maintain a make file for you. And the way it does that is just by simply whichever files you have added to the project will get added to the same make file. Now, some of these are headers, some of these are source files, and you don't actually have to perfectly organize it, but it's recommended that you do. So for example here, this is a text file just with a custom extension. I can maybe move that to resource file since it's a resource, and then maybe move my header files to this header file folder. Not necessary, it's strictly for organization's sake. Okay, let's get into how the debugger can actually help us. So I'm going to open this up. And the intention again, right, of a debugger is that it's going to help us fix our mistakes. So really quick, let's just run through this program and see what happens when we run it. This is an old assignment that I gave in a previous semester. And the point of this was that it implements a RPG system inventory where a player can pick up items like healing items or weapons or MP restoring items, right? Is that they can pick all of those up. And I've written some code here, right? And in this main, what I'm doing is I'm using this inventory class, you see, and then I'm creating the inventory and then just testing if it works. So I'm testing, is it possible to resize it to a bigger inventory? Can I make it a bigger size? Adding items to it using this push back and this add items, and then expanding it, right? So it gets bigger, and then we add some items and deallocate. The intricacies of this isn't necessarily important, but as long as we have some idea that this is a data structure that represents an inventory for an RPG system and we're adding items, then we can maybe look at the output and get an idea if it's working or not. I've intentionally added some bugs to this. That way, when we run this, we should see that there are going to be some issues. We see that it compiles first off, right? And that it runs. So looking at this, let's see if this maybe makes sense. We see that it creates an empty inventory. It says expanding inventory, and then the inventory expanded from 0 to 0. Now again, we maybe don't have all the details about this, but if we think about it, if you were to expand something, I don't think it really makes sense for it to be of size 0 and then expand to another size 0. So I think there seems to be a mistake with the expansion. So if I get an idea of maybe where there's a difference between what I'm expecting, either if I worked it out on a piece of paper or if somebody's given you some sample output for a class, then we can have a rough idea of where that line is where this is an issue. So it seems like this creating an empty inventory is probably okay. It seems to start with a size of 0. There's 0 things in this. That seems to be what the word empty means, so that maybe makes sense to me. But the expansion seems to not make a lot of sense. What you can do is you can pause the code at the place where you think there's a mistake, or at least somewhere close. So here, I think this section of the code seems to be a mistake. There seems to be a mistake somewhere in there. And it might not actually be in my main. It might be in some of these functions that are getting called. So what I'm going to do is I'm just going to pop what's called a breakpoint. You'll see if I scroll over this gray bar on the side, this circle appears. Now if I click that circle, it'll turn red. And what this means is that the code will pause on this line. Now I probably shouldn't put it there. I'm going to put it one line down. The reason being this is just a comment, so it's not a real line of code. What will happen if I run my program is it's going to start at the top, right? When we start a program, it begins at main, and then it will execute each line one by one. The moment it hits this red guy, called a breakpoint, it's going to pause the execution of your program. Now, you can also do a breakpoint with F9. You'll see I'm not clicking anything, but if I hit F9 on my keyboard, it makes it appear or disappear. And if you don't remember that, that's okay. Just hit the debug window, and the toggle breakpoint is also available. So we want some sort of breakpoint in order to do this. Now, to run this, I don't actually have a terminal. There is some kind of terminal down here that's showing me the output of building, but it's not actually like the real terminal. This is the terminal that it pulled up when it actually ran, right? But when I started, I didn't have a terminal. To create that, you'll notice that originally I hit this green button that said local Windows debugger. Now it installed the debugger when I installed this, and if I hit this, it will run this program with a debugger. So let's actually see what the debugger looks like now. When I run this, you'll see that it created these two windows. This is the actual debugger information that I'm getting. So looking at the terminal, it said creating empty inventory, and then we see this yellow arrow on the left, which represents which line of code is currently being executed. So this line has been executed, or is going to be executed next, and then it will show me all of the variables. So you'll actually see we have these 3 locals in main, inventory, previous size, and items, and it actually shows me them right here. If they are classes or data structures, you can see that by clicking on this arrow on the left side of the variable, that it will also show you the members. So for example, this inventory, if I look at it, it's an inventory object. And if I go to inventory.h, you'll see it has an items array, a count, and a size, and then this constant inv sizes array, right? And we actually see all of those per every inventory. This can be really helpful if you have multiple objects. You can view each of their members independently. And then you can also collapse it. That way you don't have to see it all on the screen at the same time. Okay, so we can continue on a little bit. You also see that some of these might be uninitialized, right? So this previous size, for example, hasn't been set yet, and it's not anything. Okay, so continuing on, it seems like we haven't actually got to the expanding inventory part yet, so maybe I need to run through a little bit more code. In order to go to the next line of code, you can do one of a few things. You can step into, which is this button up here. You'll see that it also is F11 on my keyboard. By clicking that, you'll see that it pulls open the terminal, and what it did is it printed that expanding inventory, since that's where the yellow line used to be, the arrow, and then moves to the next one. So when you do a step into, it simply steps into the next line of code. When I do this next one, you'll see that I have this step into. There's a yellow right here, and what I'm going to do on this line is I'm calling inventory get size, which is a function in the inventory class. So when I hit this, you'll notice that we jump over to inventory .h, where that function is located. So it'll jump over to the function that you actually have called. And you'll also see on the right-hand side that it updated my call stack. Now, the call stack, if you're not familiar already, simply shows you which functions have been called and in what order. So you'll see get size is currently on the top of this stack and main is below it because the line in main, line 22, called this on line 29 of my inventory.h. So it'll actually show you which functions have been called and in what order. And if I went to double click on this, it will actually go back to that function so that I can view those variables. I can either view them in this locals right here, this locals window on the bottom left, or by scrolling over the variable, it will also show it to me. Returning to the function that we're actually looking at, it seems like this function is pretty simple. I don't think I made a bug here, right? It's just a getter that returns the size, so maybe we'll leave that one. Seems to have worked fine, so let's step into again. We see it's going to now call this upgrade function. The previous size is set equal to 0, so it seems like this variable has now been set, and that seems to make sense to me, right? So looking through this, we started with an empty inventory. It seems like the size of something that's empty would be 0, so to me, this seems okay so far. So no bugs. We can maybe keep stepping through this until we identify something is not as we think it should be. Stepping into this, we see an upgrade. What this will do is it gets a size to upgrade to and then tells it to resize. So looking at this really quick, we're going to get a size for the level. That seems to be a simple function. It returns it. Stepping into here, we see that the new size is 4. You'll also notice that if you run code and it modifies a variable, that it will change to be highlighted in red, which is very helpful. It will tell you what has changed since the last time you hit one of these buttons. Okay, so it seems like what we're doing here, if we had maybe the context is we're trying to resize this inventory system from size 0 to size 4 so that it previously held 0 items and now holds 4. So it seems like we're getting the correct variable here. It says new size, and then we're jumping into this resize function. Okay, I've written code to resize the inventory, so it should go from an existing array and then make an array of this new size with all of the same information inside of it. So looking at this really quick, I might say, okay, well, I have some expectations of what's going to happen here. It's going to make a bigger array, and then the size of this is maybe going to be different. And so maybe what I do is I want to go to the end of the function. I can maybe hit another breakpoint, and rather than skip over all of these by hitting F11, you'll actually notice if I was to do that, it's going to be, it could be kind of annoying because there's a for loop here and it might have looped a few times. If you hit the continue button, it will actually just go and run as many lines of code as you'd like until it hits the next breakpoint. So if I had done that previously, it would have skipped all of these and gone straight down here. And maybe I shouldn't say skip, but it would execute all of them without pausing. Is maybe the way to do that. So looking at this, we now seem to be at the end of the function, and maybe we want to evaluate some of our information. So it seems like after running this, the items array is still null. Okay, and the count is 0, the size is 0. So what seems to have happened is maybe we wanted the size to be 4, we were given this new size, and it doesn't seem like it got set. So that maybe instigates to me that, oh, there's a mistake here, right? This function is supposed to resize this thing, and the size should get bigger over time, but it's definitely, this variable seems wrong. We're intending for this to be of size 4. So once you notice that, you can actually maybe fix your code. So the line of code that I removed here should have been that the size is equal to the new size. And this should now at least partially work. Let's run it again really quick. And we see that it pauses, so it pauses on this expanding inventory. I'm just going to hit the continue to see where it goes, and we see that it gets to the end. So we now have press any key, expanded the inventory from 0 to 4, from 4 to 10, and it seems like I've now fixed this mistake. This array is now getting bigger like I intended it to. The debugger can be very helpful for this because rather than having to put a bunch of cout statements, you can simply go to a specific point in your code and then have it pause there, and then you can verify whether all of the variables that you're actually intending to use or intending to be set that way are set that way. My biggest tip when you're actually using the debugger, so again, it's a tool, you have to have some amount of input, is it helps to at least illustrate the power of functions. If you describe what a function is supposed to do and you know exactly what the output is supposed to be when the function is over, it can be very helpful for you. So for example, when we were working through this guy, now we weren't given the assignment here to know the exact details, but if we have some description of this, that it resizes the inventory, right? So normally I would leave comments here that say something like resizes the items array to be of the new size, then I might have some idea of what those variables are supposed to be. So I might say, by this line of code, the last curly brace, the size is supposed to be the new size, all of the elements are supposed to be copied over, and I have some general description. So what I highly recommend you do is you need to make sure you understand what you're writing. It is the most important part of coding. And if you have an idea of what you expect the answer to be, you should know what the answer to your function is supposed to be, what all of the variables are supposed to look like. Stop it at the end of a function or at the end of some section of code and say, okay, I'm going to look at all the variables. Are they all what I expect them to be? And I noticed then when I was running this originally, my size was 0, which maybe doesn't make sense if I'm resizing it, making it something bigger like this new size. Right, so this is just a tool. It can be very helpful for identifying that. I'd like to just go through a few more features that are available while we're talking about it. Now, you'll notice here, I skipped over this for loop originally because it was going to take a while. If the count was something like 5, we'd actually see that this would take a while. So what I'm going to do is maybe F9 here, and then we'll skip a little bit forward. So if I was to continue, and then continue again, you'll see it pauses here, and it's going to have an array that currently has 4 things in it, and we want it to move to a new size of 10. So you see if I was to execute this, it's going to do the for loop 4 times because there's 4 things in this array. Now, 4 is not very big, but I'm sure you've worked with programs where you need to do a for loop hundreds of times, right? Maybe like 100 times, 1,000 times, something like that. And for some reason, maybe your code breaks specifically when the count or when the I variable is equal to a certain value. Like you see that it breaks at 96 or something. Now we don't want to have to keep clicking through that. That seems really annoying. There's a common feature that's really useful. You can set a breakpoint, and then you can do what's called a condition on that breakpoint. So what I'm going to do is I'm going to right-click this breakpoint. I'm going to hit conditions. What I can do is say something like I equals 3. And what will happen is this breakpoint will only stop when this condition is true. So you'll notice in the context of the for loop, I have this I variable that I'm using to count through the array. And what I can do is I can tell it to stop specifically when I equals 3. When I ran it the last time, you'll notice that it stopped when the for loop initiated for the first time. But if I was to run it now and do the continue, then you'll see that it didn't stop whatsoever, which is definitely not intended. Maybe I should move the breakpoint down just to be safe. So let's that might be a mistake on my part. Let's do an I equals 3 here. And if I run it and continue, then you'll see it stops on this line. So I apologize. I think the reason it didn't stop is the for loop up here. I think it was just doing only the statement. But you'll see if I scroll over I, it stopped specifically when it was 3, and we can see that down here in the locals as well. So that can be very helpful if you only want it to stop some of the time. You know this bug only occurs when this condition is met. You can type that condition in by, again, right-clicking the breakpoint and doing conditions. Right. And you also see, I think it's worth illustrating that the call stack can get bigger. I have 2 functions now, and we can see that it calls both of them, and you're allowed to view those variables. So this was at least a quick setup for the debugger. I'd like to do one quick other example. Now, when I created this for the first time, it created something called a solution and it created something called a project. And I didn't really mention what the difference between those two things are. The solution is going to be your entire code base. So you'll find in practice that when you write code, you might be writing several programs. They might be in the same language, or they might not be. Like if I was writing a whole application and I had a Python script that maybe helped me organize my resource files, and then I have my actual C++ code that's used for my mobile application, then I might need to create two separate programs from those two separate things. The solution is just what you're trying to do, like everything that's related in some way. The project is a single program within that solution. So you'll see here, it happens to, when you create your first project, name it the same thing as the solution. So I have one project, this guy in red right here, and then a solution. What I can do, if I want multiple programs, is I can do right-click, add, new project, and then it gives me the same window, right? So in this case, I'm going to make another empty project maybe, and then I'll do my second program. And I think I misspelled that, but we'll just kind of ignore that for now. And so what you'll see is that it allows me to do two of these separate ones. This can be really convenient if you need to compile multiple of these. It will keep a separate makefile for each of them. And you can also share your files without having to make two different copies of them. So for example, here, if I wanted to copy over these and maybe my resource file, then you'll see I can make them be in the same program. And if I was to modify them in one, like if here I decided to change this to be inventory without a that, and then I access it in my original, so I modified that in the second program, but if I look at it in the first one, that it modifies it there too. So if you're writing a class and you need to reuse that class multiple times across different programs, for example, you have the ability to reuse it. But if I wanted to modify things, like for example, in this program, I had multiple mains. So this main.inventory.cpp has a main in it, and I might want to write multiple mains that test different things. So here, what I'm going to do is I have another one. I'm going to go grab it. And if I go to maybe where I actually have this, which was in CS202, so we have teaching courses, CS202, 2025. And then I go here to my solution. I have another one, maybe called like main scripted, I think is one of them. Oh, I have that in here. Main scripted, right? I can import that. And then I just need to update this actually. And you'll see it allows me to have a completely different program that it will compile. So here, this file, for example, has a main in it, and because any of your programs can only have one main, I can create one program here with the second program and one program here with the debugger example, and they'll compile separately, right? So if I want to build this guy, for example, then I can click on it, and you'll see it just runs the test that we did a second ago, right? That runs through and then pauses, and then if I decide, okay, I'd like to run this second program, I can click over to that, and then run it, and it should do my second program instead. Now you might actually need to change this, so I suppose I should do that. Oh, I need to kill it. You can do this in a few different ways, but one way I tend to go to is if you right-click on this and then hit build or debug, either one is okay, start new instance, it will run it on a different program. So for example, if I run it here, you'll see that it will run it, and I appear to have some sort of compiler error, so maybe I have some mistake in this that I need to fix. Cannot open inventory.h. Now that I don't know why it's doing. I didn't think I made a typo, but maybe I have one. But that's okay. We'll kind of live with that. But if you wanted to create multiple programs, right, you have the ability to do that and then debug them separately, which again can be very helpful. One final thing I'll mention before I leave you is you'll notice that we no longer launch the program from the terminal. So what you might be used to when you first started programming is running G++ and then doing ./a.out, but now it just kind of does that for us, right? Maintains a makefile, compiles for you, runs for you. What we lose by doing that is that we no longer have the terminal to type in command line arguments, and so we need to be able to do that. You can actually set that by going to Project, and then Properties, and you'll notice it has this debugging one. So I'm going to click on this debugging, and that's where our command line arguments are. So you can type these out as if you were actually using a command line argument. You don't have to put the / part, right, because it's always going to run the program. It's simply the command arguments that come after that. So things like your text files or parameters that tell you how to run the program, something like that, right? You now can still set those even though we're not working in the terminal. There's a lot of other customization options that exist in the debugger. You can get into a lot of technical stuff, but if we were to explain that, we would be here for 10 hours, right? It would take a very long time. So the intention of this video is I'm just very frequently asked, how do I use this debugger? It seems like it's a little complicated, and I wanted to provide this as a resource if you're thinking about learning how to use a debugger. Very highly encouraged to use it. Get used to looking at locals, looking at the call stack. It will be very helpful in the long run. So I hope you found some sort of use in this, and I wish you the best.